Good afternoon. I'm Fraser. My Twitter handle's up there. And I am going to tell you about the Let's Encrypt initiative and the ACME protocol which underlies it and how it does its thing. So first a bit about me. I'm a developer at Red Hat. I work on the dog tag certificate system, which is a certificate authority and OCSP responders, token management systems and so on, and the free IPA identity management suite. At work, I'm mainly using Java for dog tag and Python for free IPA, but for my side projects and outside of work, I'm mainly writing Haskell these days. Yeah. All right. So I'm going to talk about deploying TLS and what it takes to do that securely today. And I'm going to talk about the Let's Encrypt initiative, which is hoping to provide a better way of doing that. And I will briefly explain the mechanics of the ACME protocol. There will be a live demo, which I haven't checked if it still works, so hopefully it still works. And then I'm going to conclude with a discussion of some of the implementation and security considerations and some possible future directions for the initiative and for the ACME protocol. So deploying TLS. First of all, can I just have a show of hands of anyone who has not ever done a certificate request and domain validation with a public CA in order to deploy TLS? Has anyone not done that? Like how many people? So there's only a few. Most people in the room appear to have suffered the trauma of doing that. So basically the process today involves paying money to a certificate authority. Usually there are some free ones, but most of them charge money. That's point 0 because that one doesn't necessarily happen as the first step, but the next 3 are in order. So you have to prove control of a domain for a domain validation certificate, which is an ad hoc process. There is no standardization around this process. Then you have to request a certificate, and there are many different certificate request formats and processes for actually getting that certificate request to the certificate authority or CA and getting a certificate back. And finally, once you've acquired the certificate, you have to configure the server software to use that certificate. And this is typically a non-trivial process. So I've just got some screenshots of what some of the public CAs say about domain validation. So yeah, validation of domain ownership is acquired through a link that you need to click on being emailed to you and your email address associated with the domain. There are some alternative ways to do it, uploading a file to your website's root or creating a CNAME record in the domain name system, DNS. But yeah, the whole click on a link being emailed thing just fills me with concern the moment I see it. There are ways to do it securely. I'm willing to bet that at least a few of the CAs out there are not doing it securely. Here's another one, Network Solutions. They say that domain validation is done using an established and accepted process. Well, established, yeah, kind of. Like there are some common ad hoc ways of doing it, but there's no formalization whatsoever of the domain validation process and no convenient way to automate it. And accepted, accepted by whom? Accepted by those who can tolerate doing it. I'm willing to bet that there are a lot of people who have not deployed TLS because they just gave up in frustration. People who weren't necessarily sysadmins or people experienced in these technologies who just throw their hands up in the air and say, oh, it's too hard, I'll just serve it insecurely. It's not a good state of affairs. We can do a lot better. But let's look at the certificate request process. So if you're on a Unix machine, you issue a magical incantation, OpenSSL, rec, no DES, new key, blah, 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 WAT. You can read the man page and find out what this means. If you're like me, you've done this many, many times, but you still have to look at the man page every time you want to do it to work out what was the magical incantation that you had to issue. Make sure you put the right information into the right fields. The domain name is actually the common name in the distinguished name. And, if you don't know that, if you're lucky, your certificate authority will detect that in the request and say, well, you seem to have made a mistake there. If you're unlucky, they'll just issue a certificate with completely, whoa, just had a light explode over there. If you're unlucky, they'll issue you a certificate with just completely bogus information that the browsers won't accept. And then having done all this, you just open up the file and copy and paste it into a field in the web browser. And again, this is just annoying. There's way too much involved than there necessarily needs to be. For configuring the server, you've got to configure the certificate chain. Oh, we've got some smoke blowing past now. Great. Different servers have different configuration for the certificate chain. Some of them have the end entity certificate configured, in its own file, and then the rest of the chain in another file. And again, there are a bunch of different formats. The default TLS configuration in most server software is, in this day and age, insecure or at least inadequate. If you look on the web for, what are the correct TLS settings? Well, too bad if you looked at anything that's, 6 months old or older than that, because if you do what it says in the article, you won't be deploying TLS securely. And then you got this SSL ciphers directive and this great big thing, which is like, that's crazy. Like, it's what you need to do to deploy TLS securely today. But, it shouldn't have to be this difficult. So that's kind of what the Let's Encrypt initiative is all about. So Let's Encrypt is an initiative to encrypt the whole web. It's being driven by the Electronic Frontier Foundation, Mozilla, the ACME CDN mob, Cisco, who make network equipment. I'm sure most of you know this, and Identrust, who are a public certificate authority with their root in the trust stores of most browsers and operating systems today. They're going to provide a free certificate authority, and they're going to provide ways to automate domain validation and certificate installation. And the way that's all going to work is using the ACME protocol. And I will delve into a bit of an in-depth look at ACME in just a couple of slides. First, let's talk about what some non-goals are. This is not a replacement for the X509 PKI or the certificate cartel. You can still give money to a certificate authority if you want to have a higher level of validation, if you want to pay for an EV cert. So yeah, well, exactly. So, and it's the experience for a user on the computer is no different at all. A DV, domain validation certificate, will be accepted by a browser. So, what's the big deal? Well, they just want to, shake down large companies twice. Well, okay, everyone wants more money, so fine, but yeah, it's easy to look at it and be disgusted by the industry at the moment. It's not intended for automating or replacing these higher forms of validation. And again, if your eyebrow is raised by that sentence, well, that's okay. Mine is too, but we need to talk about what the goals of the project are and are not, so that's not one of them. And it's not intended to be useful in private or institutional deployments of X509, although it turns out that the client automation of certificate installation and configuration of server software will probably end up being useful in those sorts of environments. The ACME protocol itself, perhaps not, but we'll see. So ACME stands for Automated Certificate Management Environment. There's provision in the protocol for the automation of domain validation via the issuance of challenges by a certificate authority to a client, and the client will do some work in response to those challenges, send some data back to the server in order to have the server validate that the client has control of a particular domain that they're interested in acquiring certificates for. It manages the certificate lifecycle, so you can request new certificates, renew certificates, and revoke them. And finally, although it's not actually part of the protocol, an important part of this initiative is that the clients will automatically configure the server software and install the certificates in the manner that is appropriate to the server that's being configured. So, brief overview of the protocol. A client will generate an account key pair. It will with that account key pair, ask the server for some challenges to validate a domain, and it will satisfy those challenges or attempt to do so. And having satisfied them, the account key is then authorized to request and revoke certificates for that domain name. There's a REST-ish API with the protocol. And finally, as mentioned, the client request objects are always signed using the account key, using the JWS, JSON Web Signature object format. Key registration looks something like this. So you post to some new registration resource an object that contains some contact details signed by the account key. The contact URIs are used for recovery and or notifications of account events. And there'll be a location header in the response that will allow a client to update the contact details should they change. And there'll also be link headers which will inform the client as to where to go to request authorization for a particular domain name. That's what this slide's about. So you can post to new auth said. Now this is not actually specified by the protocol, which is why those link headers are important. But I imagine that most implementations will standardize around a common set of paths. So it'll post an identifier, type DNS value, the domain name. This structure is designed such that the protocol could be extended for other use cases, but at the moment there's only one type defined, and that's DNS for domain names. You'll get back an object that looks something like this. So you'll get a pending authorization for the identifier, as was included in the request, and a particular account key, and this is pulled from the JWS header. And then a series of challenges. In this case, there are 3 challenges. One is simple HTTPS, one is DNS. We'll look at each of them in a minute. One is recovery token. I'm not going to explain that one today, but you can read the spec if you're interested. And finally, combinations, which is basically saying the server policy around which sets of authorizations will, or which set of validations will constitute an authorization should those validations pass. So in this case, either index 0, simple HTTPS, and recovery token, or DNS and recovery token will satisfy the server as to the control over the domain that the client excuse me, that the client has. There are 6 validation challenges at the moment. More may emerge. So there's simple HTTPS, which is basically a formalization of the, hey, just put a file on your website somewhere, and we'll go and check that you put that file with some certain contents. DVSNI, which is domain validation by server name indication, which has the client sign a custom certificate and then set up a host within the server software such that when the server contacts that host with a particular value in the server name indication TLS extension, the server will respond with this custom certificate, which will contain the information that the server will validate. Sorry, and when I say when I say server here, I'm talking about the ACME server, so the certificate authority. Then there's DNS, which is provisioning a particular DNS record for the domain. These 3 final ones, proof of possession, which is used to prove control of a already trusted key, and that's already trusted by the ACME certificate authority. For example, if you already have your a certificate signed by VeriSign, and if the ACME server trusts VeriSign, then they might say, okay, well, if VeriSign signed you, then we'll sign you too. Then there's recovery, contact and recovery token for handling lost account keys and so on. A simple HTTPS challenge looks like this. So you have, well, type simple HTTPS and a token, which is just some ASCII with minimum 128 bits of entropy. The client has to put this content in a file, which it will serve up using TextPlain. And the client can choose where it puts it on the server as long as it's under the path .wellknown/ACME challenge. It decides the rest of the path, and it includes that path in the response. When the ACME CA receives the response, it can go hit the server and try and request this file, make sure that the content is in the file, and if it all checks out, then that validation has passed. DVS&I is a bit more complex. Actually, it's a lot more complex. The challenge contains R, which is a 32-byte random octet string base 64 encoded, and a nonce, which is a 16-byte octet string, random 16-byte octet string, hex encoded. Upon receipt of the challenge, if the client chooses to respond to this challenge, the client will then generate S, which is also a random 32-byte octet string base 64 encoded. That it will include in its response. Now it provisions a host on the server at nonce, so it's this value here, .acme.invalid, and it signs a custom certificate self-signed using the account key with a subject alt name extension containing two domain names, one being the domain that is being validated and the other being this thing, .acme.invalid, where this thing is the hex encoding of the SHA-256 digest of the concatenation of the server nonce and the client nonce R and S. Now, when the server receives the response, it will contact the server, commence a TLS handshake. It will use this host name in the server name indication extension, and it will examine the certificate it receives back and check these aspects. So it will check that it has subject alt name with the domain name being validated and the appropriate this thing, .acme.invalid. DNS, fortunately, is a fair bit simpler. You just get a token and you have to provision a text record for underscore ACME challenge domain being validated in TXT and then this value. And there's actually no additional information included in the response to the ACME CA. It just says, hey, I've responded to your challenge. You can go and check that the record exists now. If it does, and if the value matches the token, then that validation is passed. As I said, the other three, proof of possession, recovery, contact and recovery token, I'm not going to go into, but they're specified in the document, and there's some links at the end of the presentation. So, assuming enough validations have been passed to satisfy the server policy, you can now post to a new cert resource. Again, this is not fixed in the protocol itself, but it's something that it can be discovered via link headers in earlier request response cycles. The new certificate request contains a CSR and a list of the authorization URLs that the client has responded to. And again, this is all signed by the account key. The CSR is a PKCS10 DER object base 64 URL encoded. A client can request a certificate from multiple validated identifiers, so any identifiers that have been validated for that account key can be included in the certificate, and they're just going to appear in the subject alternative name extension. And if this is all successful, then the server will respond 201. It must include a location header to a resource where it can retrieve the certificate, and it may also include the certificate in the response directly to save a round trip. Revocation involves posting a revoke message to this resource here that was given in the location header. So again, it's very resty in terms of none of the paths are actually fixed. They should all just be learnt along the way by the client. So you post to this resource the revoke message, revoke now, which is an RFC 3339 date, or the literal string now, and the relevant authorizations. And alternatively, you may sign this with the key that is on the certificate rather than the account key. And if the server is satisfied with the authorization of the ACME client to issue the revocation request for the certificate, then it will just respond 200, and that certificate will be revoked and appear in CRLs or OCSP responses accordingly. Okay, So I hope you're still holding on after that little bit of a deep dive. So it's demo time. So I'm just going to run a demo server using a CA that I've created. So this is not using the public demo CA, but there is a public demo CA you can use. Okay, so this is running, and this is just spitting out the details of the certificate. I have installed this CA certificate in my browser, so when I do the ACME request and the certificate is deployed, we're not going to get an error. Oh, don't do that to me. Okay. Just bear with me a moment. Okay. Right. Yeah, well, it's not going to be a demo if something doesn't go wrong, right? So this is just, well, it's just a flat file, hello Brisbane, on crikey.ipa.local. There isn't actually an IPA called IPA because I work on free IPA, that's all. So don't read into the domain name too much. But yeah, this is being served over HTTP. There's no security at this point. So if I go HTTPS, hit that, well, we'll see that the port's open, but we're not talking TLS at all. So there's no certificate for this. The TLS isn't set up properly. Okay, so now this is on the web server, and I have a ACME client here. So if I do sudo, which let's encrypt. Yep. And I'll say server acme.ipa.local. So this is the host that's running the ACME server, this chap over here. And domains crikey.ipa.local. And I'll put in my password. Okay, so it's going to fire up the ACME client. This is a preview release, yada, yada, yada. This software cannot obtain a publicly trusted certificate for your web server. Well, not yet. That's okay, because I can still show the demo. So now it's doing the DVSNI challenge and creating the vhosts and all of that and the Apache. And yeah, it's done. So if I go back here now and reload this, voila, we're serving this over HTTPS. So verified by ACME demo CA, so this is the CA that I've created, and I've installed its certificate in my browser. And yeah, if we view it, details, well, yeah, there's the chain. Okay. It's also going to give us the option to do some other server configuration and make a permanent redirect from the HTTP site to the secure site. So yeah, we can turn that on, and that's just going to set up a 301 permanent redirect. So if we go to, say, Apache 2, sites enabled, so crikey.conf. So this was what was here before. So the vhost, server name crikey.ipa.local document root bar dub. This stuff here has just been added by the ACME client to set up this rewrite rule. And for let's encrypt ssl.conf. So you can see if module mod SSL, server name and document root same as before, and SSL certificate file. Well, let's encrypt 6.pem, let's encrypt 15.pem for the certificate key file. So as you can see, I've run this demo a few times before. And then including the default TLS configuration, which will be used by all the hosts. Currently, the ACME client doesn't update this if if, for example, a new release comes out and they've updated the default TLS configuration, I don't think it is going to go and update this at this point, but there's no reason why it couldn't. Okay. So how are we doing for time? How much time have I got left? 5 minutes? Okay. So what's the status of the initiative? The client and the server are still under heavy development, and the ACME protocol is still evolving. This demo code I'm running is actually before they changed from an RPC-based API to the REST API, so it's quite old, but yeah, I didn't want to touch it because then I'd probably be running around in circles trying to get a working demo for my talk. There's an Nginx configurator in the works as well. Currently, that only works for Apache. And they're aiming for a mid-2015 launch of the public CA. In terms of the protocol evolution, the original protocol was RPC-based, as I mentioned. They've moved to a REST-ish interface. This does change the security characteristics. For example, there are more HTTP resources exposed on the server, which means more endpoints where you're going to have to check authentication and authorization of the credentials that are presented by a client. And in fact, there are some concerning aspects in the protocol now where, for example, with the registration resource, there's the server should not respond to a GET request for a registration resource. Well, that really ought to be a must not, because depending on how the registration resource paths are assigned, if they're sequential, that means that if a server does actually allow people to get them, then you can just walk through and just mine all of the contact details off the server. So yeah, there's, I think, a bit more work that needs to be done in the protocol to make it actually secure in all respects. Finally, it's worth mentioning that they switched from a custom signature construction, which also was not entirely secure, to JSON web signature construction at the same time as they moved from the RPC protocol to REST. So they did take that opportunity to make some other major positive changes to the protocol. The future. So in terms of adoption, I'd like to see support for all the popular HTTP servers. So on Unix, that's going to be Apache, Nginx, Lighty, Light, TPD. Goodness knows how you actually pronounce that. IIS for Windows. I don't know what other servers there are. Maybe some of them big application servers as well. I'd like to see support from multiple public CAs for the protocol, even paid ones, even though the payment would be out of band. There's no provision in the protocol for any sort of payment step, but the protocol itself, I think, is quite useful in terms of the formalization of the domain validation and the certificate request and revocation lifecycle. So I think that there would be a lot of value in existing CAs adopting this protocol in terms of the user experience and seeing TLS deployed in more places. And finally, uptake by platform as a service providers, I think would be a huge win, because it means as soon as the DNS is pointed to the PAS provider, if you're using a custom domain, that PAS provider can then go and provision a valid certificate for that domain on behalf of its user. I think that's a huge win. And for infrastructure as a service, they will actually control the DNS usually. So there's even less work to do for a user such that they can get valid host certificates, for example, that will be accepted across the board by existing software. We might see some new validation challenges. They've flagged DNSSEC, email, and whois. I think DNSSEC is really the main interesting one there. Other side effects, if the initiative is successful, we will probably see better server configuration mechanisms or APIs. That's a huge win, and that would also enable other benefits, like, for example, if you have a trusted service that tells you what is the secure way to deploy TLS today, then you could have a service that goes and just checks that periodically or waits for a poll, and then goes and updates the server. So when Heartbleed comes along, or when Beast comes along and suddenly, oh crap, I have to turn off TLS compression, that sort of thing could happen automatically. The CA cartel might not like this initiative. Will we see countermeasures? Will we see something like EV, some new round of hand-wringing over how can we get people to still pay us money. We might. Will we see attacks against the Let's Encrypt CA or the protocol itself? Yeah, we might. See what the future holds. Okay, so that's pretty much all I wanted to say. You can get involved. There's like, all the code's on GitHub and there's IRC and all that, but this is the main one you need to remember. Let'sencrypt.org. Everything else, the mailing lists, etc., you can find from there. Okay, that's all. Are there any questions?